Okay. All right.
Okay, so today we're learning about arithmetic sequences. So yeah. Okay, so what are arithmetic sequences? In an arithmetic sequence, each new term in the sequence will increase or decrease by the same amount each time. So some common arithmetic sequences to help you show what they are is this sequence 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. These are positive integers, and in this sequence, each new term is going to increase by 1. Another common arithmetic sequence are the even numbers or even integers. In this sequence, you have to add 2 to get the next term. And also you have the odd numbers, which you add 2 to get the next term. But notice that even though you're adding the same amount to get the next term, your starting term is different. So that gives you a different sequence. And finally, arithmetic sequences can also have negative numbers. So for example, here we have we subtract 2. Oops, well, whoops. Well, for this one, we are subtracting 2, but subtracting 2 is basically the same thing as adding negative 2. And it sounds weird to be adding a negative number, but mathematically, in general, we sometimes will say we're adding a negative number. So just be aware of that.
Give me a quick second. I'm just putting the attendance down. Okay, I'm all good. So, all right. So what else should you know about arithmetic sequences? Well, arithmetic sequences. Well, every time you use arithmetic sequence, you're always going to add a number, and this number will always stay constant, and that's what we call the common difference. If you're adding a negative number, basically you'll be subtracting. The common difference will be negative. Let's see some.
Yeah. So,
all right.
for example, in here, what is the common difference for this sequence?
You can just put it in chat. 3. 3 is right. So yeah, the common difference is 3 because 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 11 is 8 plus 3 is 11, and so on.
Okay, here's another example. What is the common difference?
Let me check chat. Right. So negative 23 is the right answer because we're actually subtracting 23. Since we're subtracting 23, instead of adding, we would say the common difference is negative 23 instead of 23.
So you would have to include a negative sign.
And this is the final rule, I think. Final problem. So what's the common? Yep. Yeah, so it's 0 since we're not adding anything. So
yeah, it's plus or minus. You could just write 0. So yeah, you need to make sure to put the plus sign, or just like leave out the plus sign if you're adding the number, or you need to remember to put the negative sign in front of your rule. So yeah. And also, when you're trying to identify if a given sequence is arithmetic, you need to make sure the sequence is following the same rule throughout the entire thing. Because if it doesn't, then it's not an arithmetic sequence, or you might get the wrong answer. Okay, so here are a couple things to keep in mind. The numbers, or like terms, in an arithmetic sequence can be anything. So they can be integers, they can be negative, they can be fractions, etc. They can also be decimals. And the distance or the common difference of the numbers can also be anything. That can be negative, that can be fractional, etc. And finally, some sequences aren't going to be considered arithmetic sequences because in an arithmetic sequences, the common difference has to be the same throughout the whole thing. There are some sequences that have like a special rule that changes a little bit. Like for example, in this sequence here, the rule is +1 or +2 and then +1 and then +2 and then +1. These sequences aren't true arithmetic sequences, but these sequences may come up occasionally in some tests like written assessment, but these are not arithmetic sequences, which we'll be talking about today.
Is it working? All right, so let's see if you can identify if the following slides are an arithmetic sequence, and then we're also going to ask you to identify the common difference and also the next term. And you guys can either type your answers in chat. I mean, yeah, just type your answers in chat.
Okay,
All right, so identify if this is an arithmetic sequence, and if so, tell us the common difference. And be sure to use plus or minus, well, like the parity of the number. And the next term. All right, so basically when you type your answer, I want 3 answers. I want either a yes or a no. I want, if it's yes, then you're gonna put the common difference, all right? And then after you put the common difference, I want the next term. So you have to put those 3 things and they should be separated by commas or something. Don't like scatter your answers because then it's gonna be hard to see. I think most of you got the right answer. So yeah, so it is an arithmetic sequence, right? Because each number is because the common difference is 10. We're adding 10 for each term because 7 plus 10 is 17, 17 plus 10 is 27, and so on. So the common difference is plus 10. So it is an arithmetic sequence, and since the common difference is 10, the next term is going to be 37 plus 10, which is 47. And yeah, everybody like look at what Sanvi did in chat. That's exactly how I want you to format your answers because it's really easy to look at. And yeah, that's basically how I want you to do it. So next slide. So now you're gonna identify if this is a common sequence and do the exact same thing you guys did before. Give me a second. Yeah, no is the correct answer. Since no is the correct answer, you just put nothing else. So notice that between the first and second term, the difference is 4, and then the second and third term is 6. We automatically know that it's not an arithmetic sequence since the common difference is not.
Okay, for this third one, right? Again, same thing basically. Is it an arithmetic sequence? And if so, what's the rule and what's the next term?
All right, so you guys are right. It is no because the difference between the first and second is 111, and then this between second and third is just 11. So it's not an arithmetic sequence. Good job.
Yeah, this would be that weird type of sequence. I think it's called a compound sequence where the rule has a pattern, but the rule doesn't stay constant throughout the whole thing. So it isn't an arithmetic sequence.
Yes.
Oh, but in examples like 234 and 244, like the difference is 10, not 11.
Oh, sorry. Yeah, that's
Oh,
my.
no.
Yeah.
Whoops. Well, yeah. The
That's
rule
not.
was. Yeah, the rule was supposed to be plus 111 and then plus 11. Yeah, we made a typo there, but like, good job for catching that mistake.
Okay.
Isn't that a compound sequence? 111, 11, 111.
Yeah, it should be a compound sequence, but that isn't.
That doesn't count as an arithmetic sequence.
Yeah.
Let's move on.
Okay, so now we're going to look at a couple of more examples. So, okay, so an arithmetic sequence has a first term of 5 and a common difference of 3. What is the second term in this sequence?
All right. Well, we only have one answer, so I'm just going to keep on.
Yeah, wait for a couple more people, like maybe 3. Wait for like 2 or 3 more people to answer.
I mean, I think this is a very easy problem, and I don't really know why more people aren't putting in the answer. Yeah. I highly encourage participation. So yeah, the answer is 8. And that's pretty obvious, right? Because the common difference is plus 3, then 5 plus 3 is 8. And then now we're going to ask you for the third term in the sequence.
Yeah, now what's the third term?
We seem to have a lot of different answers.
No, it's just 2 people have answered. Just wait for more answers.
No, a lot of different varying answers.
Yeah.
All right, I'm just going to explain the problem. So the answer is 11, since we're just adding another 3. So 8 plus 3 is 11. And then the final one's going to be the 9th term.
Hold on, just to reiterate, when it says the common difference, it's telling you how to get from one term to the next term. So if a sequence has if this sequence has a first term of 5 and a common difference of 3, which would mean that to get from the first term to the second term, you would just have to add 3 to the first term. And then to get from the second term to the third term, you just have to add 3 again. So now we're going to sort of take a jump. What's the 9th term of this sequence?
33, 33. Everybody got 33, and that is the correct answer. It is 33. 29, yes, that's my bad. I missed it. So yeah, 8 times 3, 24 plus 5, 29.
Well,
yeah.
Hold on. Well, okay, so you guys got 33 or 32. So when you're getting if you're getting the 9th term of a sequence in the you can think of the common difference is sort of like the distance between each term. So when you're going from the first term to the 9th term, you have to add the common difference 8 times.
Because we're jumping 8 times. See, the first term is 5, and the 9th term is, well, we don't know the 9th term. So we're gonna have to jump 8, all right? And each of those jumps is gonna be 3. So we have 3 times 8, which is 24, and then we're gonna have to add that to the first term, which is 29. That's the most ideal way to do it. And I think that might be a little confusing, but
I can show it visually using the Jamboard if you would like.
I think that's the best way to go here.
Okay.
Let me get on the Jamboard really quickly. Go to a blank slide. I think go to slide 17. I can demonstrate if you want. 17.
We'll just use the second slide, Sai.
All right, second slide. Yeah, all right. So here, I'm gonna draw something really quickly. It's gonna be a decent.
Just draw a number line.
All right, so let's look at it like this. All right.
Sai, just draw a number line.
All right. So wait. Let me just do this.
All right.
If I have a first term of 5, all right, this is my first term, and I want to get to the 6th term, all right, and the common difference is 3, all right. So an easy way to, a basic way to do this would just be adding 3 here, so that'd be 8, and 3 here, that'd be 11, 14, 17, 20. But an easier way to do it is, well, look, I know that there's going to be 1 jump, 2 jumps, 3 jumps, 4 jumps, 5 jumps, all right. So there's 5 jumps, all right. So now I know that there's 5 jumps. So, and I know that each of these jumps has a common difference of 3. So in order to calculate the total number that I'm jumping, I would multiply 5 and 3 to get 15. So we're not done here yet, because I know that we're jumping 15, but we're jumping 15 from 5. So in order to get our final answer, we have to add 5. And we get our answer of 20. That's the easiest way to do it.
Yeah, and you can apply this to our other problem. Our problem had different numbers, but you can apply the same strategy. So here,
yeah, this is an important strategy, but it's really important to formalize this. So if I were to formalize this, let's say I wanted to find the nth term. So that means I would.
Yes, we're going to introduce that later in the slides.
I thought we weren't, but yeah, that's basically the basics of that. So that's how you use that strategy. So by counting each and every single term, you're wasting a lot of your time, and time is of the essence in math counts tests. So you have to develop quick-paced strategies to get the answer quickly. I just cleared the slide. You can move on.
Yeah.
So
Okay, here's another example or another problem. An arithmetic sequence has an initial term or like first term of 19 and a common difference of -7. Well, find the second term in this sequence. Oops, shoot.
all right, wait. 12, 12. Yeah, so the correct answer is 12. My bad. I'm sorry. Yeah, so the correct answer is 12 since the common difference is -7. So 19 minus 7 is 12. Okay, move on.
Okay, now apply
So
the
for this one, yeah, we
yeah,
can-
you need for this one to find the fifth term in the sequence. You could obviously just add the or subtract the common difference 4 times, but try to apply our strategy and to find the fifth term.
12 is incorrect. -16 is wrong.
You're close though.
You guys are pretty close.
You just subtracted it 1 too many times.
I saw a -9, and that's the right answer. So yeah, the right answer is -9 because, well, we're trying to get to the fifth term in the sequence. And we know that the initial term is 19. So how many leaps do we have to take? Well, that's pretty easy. 5 minus 1 is equal to 4. So we have to take 4 leaps to get to the fifth term. Well, each of these leaps is -7. So that means the total distance we're leaping is -7 times 4, which is -28. So now we know that we're leaping from 19 to negative, and then minus -20, sorry, minus 28. So 19 minus 28 is -9, and that is our answer. Did you skip a slide?
No. Here. Okay, so for this question, this diagram, the first row has 1 circle, the second row has 2 circles, the third row has 3 circles. How many circles will have to be in the fifth row? And I would like everyone to try to answer this because this is not too hard.
We need to be faster on our keyboard so we don't waste class time. There's 6 of you in here, and I only have 3 answers. So I think we need more class participation. But yeah, the correct answer is 5.
Okay, now how many circles will have to be in will be in the 100th row?
I actually want everybody to answer. I mean, I know that there's 6 of you here, but I only get 3 or 2 answers every question. So the correct answer is 100.
Yeah,
That's pretty self-explanatory,
yeah.
so let's move on.
Okay, now we're going to move on to the sum of an arithmetic sequence. So in this, the sum of an arithmetic sequence is the sum of all the terms in a sequence. And in general, when we're asking about the sum of all the terms, there will only be a finite number of terms. In other words, like the sequence will eventually end. It won't like go on and on forever. So if you have like a sequence of like 100 terms, you don't want to add all of the terms by hand. So there is a formula you can use, and here it is. The sum of a sequence is equal to the first term plus the last term multiplied by the number of terms, and then you divide that by 2. In a second, we'll show you why that works. And here's another. If you like math symbols, here's another way to write it.
Yes. Actually, I would rather, I personally use 1 plus an divided by 2 over times n. I think that's just a much simpler way to write it, but okay. Yeah. Move back.
Wait, what?
And just let them write it for a second.
Wait, I didn't hear the question or the comment.
There is no question.
Okay.
They just wanted to write it down on their notes.
Yeah, okay.
All right. I think that's right. If anybody needs any more time to write, just let me know.
Yeah,
So,
at the bottom. Yeah, there's an example at the bottom of the screen now.
Yep. Yeah, you get example. That's important. All right. I just had to move a couple things out of the way.
Once you have it written down, add the first, find the sum of the first 7 numbers.
7 numbers in the sequence. Oh yeah, just not the sequence. Yeah, just the first 7 integers. Looks 28. Yep. So 28 is the right answer. I'm gonna call on someone to ask how they did it. Jivitesh, how did you get 28?
I just added. I did a 1 plus. I did 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7.
Yeah,
Right,
that's a valid strategy.
Yes,
But
that is a good strategy. But we wanted you to use the formula. So what would the first term be? Jivitesh, do you want to answer? What would the first term be of the first 7 numbers? All right, so I guess he doesn't want to answer. So the first term would be 1. Oh, okay, Amy, you just gave away everything. So it's okay.
yeah, I should have, sorry.
No, it's fine. So in the last term 7, one is 8. One is the term. So first 20. That's how we get. There's also enough included in the lesson, but the formula for this first n numbers is n times n plus 1 over 2. So do you want to write that down? Do you want to put that on the Jamboard?
The first n numbers.
Yeah, just put n. I'll just get it on the Jamboard. Just go to the second slide.
Wait, I can type it in the chat. Sum of the first n numbers.
Yeah, but they might not get the parentheses and stuff. So,
yeah, we can show it on a Jamboard too.
Yeah, I have it on the Jamboard already. So here.
Okay. Oh, that's okay.
Oh, did I wait? Why is there stuff below that? I thought I erased all that, but okay.
No, it doesn't sync up properly.
It doesn't? Oh,
No.
I thought I erased all that, but okay.
Yeah, you did. And again, this is a formula for the sum of the first n positive numbers.
Yeah, that syncing is pretty sad. Okay, but yeah. So that it's n times n plus 1 over 2, where n is like the first n you're adding. So if I wanted to find the sum of the first 22 for the first 22 integers, n would be 22. So that'd be 22 times 23 over 2, which is 11 times 23, which is 253. All right, you can move on.
Yeah.
Mm-hmm.
Okay, so now we're going to show why this formula, the general sum formula, which is right here, why this works. So let's show how it works by using an example. So we're going to try to find the sum of this sequence. We're going to try to add up the first 11 positive integers. And you can notice that in this sequence, the opposite pairs of numbers will add up to 12. So for example, the numbers on the ends of the sequence, the first term is 1 and the last term is 11. And these two add up to 12. Then next to them, 2 and 10 also add up to 12. And then 3 and 9 also add up to 12. And 4 and 8 add up to 12, and 5 and 7 add up to 12. And then we have the number 6 in the middle, which doesn't add up to 12 because it's just by itself. But we can also notice that 6 is 1/2 of 12. So now we
basically
can,
have 5 pairs of 12, right? Because 7 plus 5 is 12, and then so on. So we have 5 pairs of 12. So that'd be 5 times 12, which is 60, and then the middle number, which is half of 12, so 66. So we
yeah,
have,
but wait, hold on, sorry, you're getting ahead of us. So we can notice that the opposite pairs of numbers add up to 12, and the middle number is half of what they're adding up to. So we can sort of rewrite the sequence like this. So we can see that it still has the same sum because the first and last number still add up to 12, and the other two numbers still add up to 12, and so on and so forth. And the middle number is still 6.
yeah, but you know what?
So then sorry, hold on. So then we can, it's pretty simple to get the sum now because we can just do 6 times 11, which equals 66. So that's, so from this we can see that the average of all the terms in a sequence is the first number plus the last number divided by 2. And to get the sum of a set of numbers, you just multiply the average by the number of numbers, which is where we get that formula from.
Yeah, I think like, you know, if you're ever gonna do this, never just like, you know, redistribute to get all the 6s. I think.
Yeah, it's just to show visually.
Oh yeah, show the visual. And but like yeah, that's basically how you do it. But I think that what is it? Wait, what's the thing again?
The formula?
Yeah, put it on again.
Can you explain the formula in each?
Yeah, I was about to do that real quick because I thought some of you guys might be confused when you just looked at that. So I was about to explain the formula. So N1, which I would have just put as A1, but that doesn't really matter. So N1 is basically the first term. So if we have any sequence, right? Any sequence, the first term of that sequence. So if I had 1, 3, 5, 7, 9, the first term is 1. And A is the last term of that sequence. So using the same sequence as before, 1, 3, 5, 7, 9. The last term would be 9. And so that means N1 would be 1 and A would be 9. And N is the number of terms. So 1, 3, 5, 7, 9. I know that there's going to be 1, 3, 5, 7. So that'd be 5 terms. So there's 5 total terms. And in order to calculate the sum, we just use all those variables. So N1 plus NA, 1 plus 9 is 10. And 10 times 1/2 is 5. And the total number of terms is 5. So our answer is 5 times 5, which is 25. Do you understand? Whoever, I think that was Sanjay who asked that. Do you understand how the formula works, or do you want us to further explain it on like a Jamboard? Because I understand the visual representation is probably.
I'm fine. I got it.
All right, cool. That's good. Move on.
Okay, so now we're gonna do 2.
Oh, somebody doesn't but you do. Don't is that a dot or don't? I think that's don't. Dot. Is that like don't or like?
Don't. It's probably don't.
Probably don't. Yeah. Okay.
Wait,
so go to the gym.
Hold on. Do you not understand why? Hold on. Sorry. Do you not understand why the formula works, or do you not understand the formula itself?
How to use it.
How to use
okay,
it.
that
Okay,
makes sense.
we can show that.
Move to the Jamboard. I think it's the easiest to work with.
Okay, I'm sorry. I'm gonna add another slide. Oh, we can't add another slide. Okay.
It's very bad relapse. All right. Wait. So is this working? Let me just draw something.
Yeah,
Yeah,
we can see it.
All right. Good. I just wanted to draw something. All right. So the formula. So basically, the formula is, I'm just gonna reiterate it. Like we just put it on once so everybody can see it. It's N1 plus NA over 2 times N. All right, so I'm going to identify each of these variables one more time. So N1, this is the first term. NA, this is the last term. N, this is the total number of terms. And 2, well, everybody knows what 2 is. So Amy, just write an imaginary sequence. 5, is that supposed to be a 5? 6, 7. All right, so we're going to use these 7 numbers that Amy wrote for us, all right? So I want someone from the, I'm going to call on someone. I want, let's see, I want Sanvi to tell me what the first term is. Actually, I'll just use you for the
1.
entire example. Okay, so the first term is 1. What is the last term? You can answer again.
7.
Okay, now we're going to divide that by 2. And how many total terms are there?
7.
All right, so simplify this for me. Oh, I can do it for, okay, so that's basically 8 over 2, which is 4. Right, so this over here in the parentheses, that's 4. And 4 times 7 is 28. Our answer is 28. So everybody understands that, right? Oh, I mean, that's the sum. So this is the sum. So 28 is the sum. So this entire formula is used for calculating the sum of any arithmetic sequence. So do you understand?
Yes.
All right. So I hope everyone understands that. If you need more help, don't hesitate to ask, because I understand this might be a little tricky learning for the first time or something.
Also, Shreyan put a question in the chat. Can this work with multiplication and factorials? So
That's another thing called geometry.
Wait, what exactly are you talking about when multiplication and factorials? Like,
I think he's talking about a geometric series.
like find the sum of all numbers in like a factorial sequence? Is that what you're asking? Oh, factorial sequences are a little weird. The formula for that is really complicated. And
I don't
they
think
aren't
I don't think
arithmetic sequences though. So you can't use this formula on them. And as for multiplication, there actually is a formula for multiplication, like if each term is multiplied by a number, and we'll actually talk about that next class, and they're called geometric sequences.
Yeah, next class. Yeah. So as Amy said, factorial sequences are extreme. Like, I mean, they're not extremely hard, but they're definitely a little more complicated than this. Like, you're probably gonna learn that way further on if you're ever going to learn it. But yeah, that's not important right now. Move on.
Okay.
We already covered this. All right. Cool.
Okay.
So now we're gonna focus on arithmetic sequences and sums. So first, we're gonna do 2 problems. So you guys have to answer this. What is the sum of the first 32 positive whole numbers? And so there's 2 ways you guys could do this. You guys could do the formula that I gave you guys earlier, the n times n plus 1 divided by 2 way, or you could do the way that I just showed you guys on the Jamboard, which is, the first term plus the last term divided by 2 times the total number of terms.
they're basically the same thing.
They are the same thing, but
Just try to use a formula for this. It's not a good idea to add all these up by hand.
I don't even think that they would, but all right. Yeah, it's definitely not a good idea.
And no,
Zero
zero would not be a positive whole number because 0 isn't positive or negative. It's just its own thing.
It's just positive, yeah. And I think you guys should I think you guys should be able to use each of these methods appropriately. You should know when to use which method. So if it was the first whole numbers, like if they were consecutive with a common difference of +1, then you should always use the way I told you, as long as they're consecutive. Like find the sum of the first, but if they're not, then you should use the other way. In this case, it is so 476. So that's actually the right answer. Wait, let me check that. I didn't check.
No, that's not quite right.
Yeah. Sorry, I forgot to check it. You're almost kind of there. Try to use the method that I showed you, the n times n plus 1 divided by 2. Yep, 528 is the right answer. You can spacebar.
Yes, so if to apply the formula, you need to first find the sum of the first and last term, which is 1 plus 2, which equals 33. And then the number of numbers is 32. So then applying the formula, applying the first formula, we can do 1/2 times 32 times 33, which equals 528. Which is the same thing as the n times n plus 1 over 2 formula for the first n positive numbers, but yeah. Okay, so now we're going to look at another problem. What is the sum of the first 10 even numbers?
There's actually a formula for this as well, but I don't think that's.
Yeah, so it's not a good idea to throw like 15 formulas at.
I was gonna say. All right, yeah. So
Yeah.
it is 110. So the way that we get that is pretty easy. So we know that the first one is. Yeah. Okay. I was about to. Yeah, but we know that the first one is 2. Well, actually, Amy, the first one could technically be like. You could have put positive even numbers. I think that question.
Yeah, it should be positive even numbers.
Yeah, but
either way.
it's good that you guys interpreted it correctly. Yeah, so the first one is 2, right? And the last one would be 20. So that's 22. And then we divide that by 2 to get 11. And the total number of terms is 10. So that'd be 10 times 11, which is 110. So good job. Move on to the next slide. There's no other examples. I don't think there's any other examples on that slide, yeah.
Okay, so now we're going to look at some more complicated problems. And so, yeah, an arithmetic sequence has a first term of 5 and a common difference of 2. What is the sum of the first 10 terms of this sequence?
Probably demonstrate this on examples. You won't get it. Definitely a little more tricky than our last one.
Yeah.
Multi-step arithmetic.
Just note that if you want, for this problem, you will need to, in order to apply the formula, we're going to need...
So we've told you that the common difference is just kind of a term. Don't really pay attention to that. You wouldn't subtract 2 from 5. It's positive 2. If the common difference was negative 2, then you would, but it's positive 2. So you instead add instead of subtract. But yeah, go ahead. We're not going to say anything until you guys...
Yeah. Yeah, for this problem, in order to apply the formula, you need the first term, you need the last term, and you need the number of terms. So we have what the first term is, and we have how many terms there are.
Let them do this real quick. Let them do it before you explain anything.
Sorry, I'm just giving them a hint. But you need to find what the last term is in order to solve it.
I think that they can do it, right? Based on what we learned. We have one answer.
Yeah, let some other people work it out.
Wait, so I think somebody else joined the meeting. Let me check.
I think Shriyam joined late.
Shriram.
Or yeah.
All right. I just needed to make sure so I could get the attendance straight.
That's fine.
Yeah. Yeah, okay. That's good. Looks like we only have one answer so far, so I'll give you guys a couple more minutes to do this problem, but I'll probably explain it in a couple minutes, so. Just a couple more. All right, I'm probably just gonna give you guys a couple more seconds. maybe get the Jamboard ready. Is slide number 2 on Jamboard clear?
Yeah, I think so.
Just check really quickly. All right, just wanted to make sure. Cool. All right, so okay, it's clear, right?
Yeah, it is clear.
All right, cool. So the two answers that we got were actually correct. The answer is 140. So good job on. Oh well, we had 3 answers. Sorry, but 2 of the 3 answers were correct. The answer is 140. So I'm just gonna explain why really quickly. So we know that the first term is 5. All right, and we know that the common difference is 2. Right, and like Amy said, we need the first term, the last term, and the total number of terms to solve this equation. We know the first term, that's 5, but we don't know the last term. What we do know is that there's 10 terms in the sequence, right? So the last term has to be the 10th term. In order to find the 10th term, we take the common difference of 2, and we know how many leaps are we taking? Well, we're taking 9 leaps, and we're adding that. Whoa, I don't really know what's going on. I think the Jamboard is acting a little fuzzy or weird. I wasn't processing what I was doing, so I think that's a little weird. That's okay. All right, let me just erase some of these.
Sorry, I can continue if you're
That's
having
okay.
Okay.
All right, so we have 9 leaps, all right, and each leap has a common difference of 2, all right? And we also have to add 5 to that because we're going from 5. That's our initial term. So 9 leaps, each leap is 2. So that's 5 plus 9 times, which is 18. That is 23. So our final term is 23, and our initial term is 5. So we're gonna have to add both of those, divide by 2, and we know that there's 10 total terms because the equation stated that. The problem stated that. So that's 5 times 23, that's 28, and divide by 2. Multiply by 5, and that's basically 28 times 5, which is 140. So 140 is our final answer. Does anybody have any questions on how I did that? Like anything at all? Is there any questions? Like if you actually have genuine questions, like it's best to ask now because I don't really know if you can ask anywhere else. Like you can ask through email and stuff, but I'll take some time to respond back to you. So if you have any questions, this is the best time to ask. All right, looks like nobody has any questions, so we'll move on.
Okay, so now you probably have noticed that you may have noticed that when we're trying to find like the last term, we have to sort of like take a certain number of jumps to get from the first term to the last term. So if the first term was like, the first term is the first term, but if the last term is the 10th term, then we'll have to take 9 jumps to go from the first term to the 10th term. So
it's not 10 jumps, it's 10 because the initial term is 1, so it's 9 jumps.
Yeah, that's what I said.
I was reaffirming what you said.
Okay, so yeah, so there is a formula to get the nth term, and in this case, n would be just a number. So there's a formula to get, if you're trying to find the 10th term, n would be 10, to get the 10th term. So this is a formula to get the nth term in a sequence. So for example, if you're trying to find the 5th term in a sequence, and you could just substitute 5 for n. You may want to write this formula down, but it's best to actually understand how it works. So
it was kind of common sense, right? Because basically n-1 is the total amounts of leaps we're taking. Imagine it like that. And the common difference is how far each leap is, right? And then we're going to be adding that to the first term to find the last term. So at the end of the day, it's really easy to understand. And I don't actually suggest that you memorize this. I suggest that you understand this, because memorizing all these formulas is just going to get, too tedious.
Yeah, I just want to formalize this just to say that if you're ever in a place where you need to find the nth term, or you need to find the last term in a sequence in order to solve a problem, you need to remember that you can just imagine it as like doing jumps, because that's a good analogy. To get from, for example, the first term to a 10th term, you need to take 9 jumps because 10 minus 1 is 9. So you would have to multiply 9 by the common difference then. So yeah. So yeah, just when you're trying to find the nth term, just try to use some common sense and think about taking jumps from term to term.
And we're gonna go to the question.
Okay, so find the sum of the terms in the following arithmetic sequence: -6, -2, 2, etc., all the way up to 38. And don't add this by hand because that would take a while.
I mean, if you forget the formula and you don't know what to do, then that's kind of a last resort. But yeah, don't. All right. Do you have any answers yet? I'm sorry, I wasn't looking at chat. 19 is an answer. All right. So actually 19 is
It's one, he wrote 192.
Oh, 19 too. Yeah, sorry. That's my bad. Okay, so 192 is the right answer. And this one's pretty easy, right? So we know Amy told us the problem told us it's an arithmetic sequence. And the first term is -6. The last term is 38. So -6 plus 38, 32. 32 divided by 2 is 16. And there's 12 terms. So 16 times 12 is 192. So that's how we got that. We're going to move on.
Okay, so again, we have these circles. So now we're going to try, the question now is asking how many total circles will be in this figure if the pattern continues if there are 100 rows.
So actually something interesting about this problem is that it's kind of a reword of a problem that Gauss solved when it's a rewording of the problem that Gauss solved when he was like a 5th grader. It's like, actually, I'll probably explain the story to you guys like after you guys are done with this problem. Pretty nice story. $50-50. All right. 50-50. Yep. So 50-50 is the right answer. And this is pretty easy. I think you guys know how to do it. The first term is 1. Last term is 100. 101. You guys already know the order of business. 101 divided by 2 times 100. 2 and then 100 crossed out to get 101 times 50, which is 5,050. And so I'm going to explain the story, right? So when Gauss was a child in elementary school, and none of these formulas really existed back then. He wasn't taught any of these formulas. He noticed something. If you guys notice, 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. 4 plus 97 is 101. 5 plus 96 is 101. That keeps on going. 7 plus 94 is 101. That keeps on going until 1 plus 100. So each of these things are 101. And there's 50 pairs of that. So 50 times 101 is 5,050. Now, as a child, Gauss was a mathematical prodigy. He was so smart. So he noticed this. And his teacher was giving him busy work one day. So no, not coincidence. All right. So his teacher was giving him busy work someday, and his teacher wanted them to waste time because teachers I guess were lazy back then. So they asked everybody in the class to solve one. They wanted everybody in the class to add the first 100 numbers, and everybody started going like 1 plus 2 plus 3. The kind of caveman method. That's what I like to call it, a caveman method. So Gauss immediately recognized this pattern, and he immediately wrote down 5,050. So yeah, and Gauss is a famous German mathematician.
And yeah, this is kind of where the formula comes from, because in the formula, we're adding up the last term and the first term, and then we're multiplying by half of the number of terms.
And then, so move on.
Yeah.
Number 12. Oh God, some bad stuff.
Okay, so does this image show an arithmetic sequence? And type your answer in the chat and also explain why or why not.
Hey, Amy, doesn't this remind you of Miss Kaiser's things? I'm going to call on someone. You did. You did. I hope I'm pronouncing that right. I'm sorry if I'm not. You did.
Pronounce it Udip.
Udeep. I'm sorry. I didn't really mean to. Okay, but yeah, Udeep. Do you want to tell us if this is an arithmetic sequence?
It's not an arithmetic sequence because on number one, like on number two, you add two more circles, but on number three you add three more circles.
Exactly right. So you're exactly right. Good job. So yep, it's not. You can move on. You don't really need to further explain that unless anybody has questions. I'm gonna call someone else for this one. Let's see. Kavya, tell us, is this an arithmetic sequence? Kavya, does she have like a mic or what? All right, I guess he's AFK or something. All right, how about Shriram? Shriram, do you have a mic? All right, sure. Yeah, I guess. Okay, Sanjay. 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 Sanjay, come on. Okay, I guess nobody really wants to answer.
Wait, Sanjay unmuted.
Sanjay, he's unmuted. Yay. All right, tell us, is this an arithmetic sequence? If it's so, or if not, why or why not?
I'm not really sure. I don't think so though.
Well,
Oh.
that's a good thing. So that's a really good hypothesis here because that is a correct hypothesis. So I think this is a really easy problem. So it's not because the first term has 1 dot, the second term has 4 dots, and the final term has 9 dots. So notice that from the first to second term, we're increasing by 3 dots, but from the second to third term, we're increasing by 5 dots. So it's not an arithmetic sequence because it could be a compact, but that doesn't really matter. It's not an arithmetic sequence because there's no constant common difference. Okay, so number 12.
And there is a typo there, so sorry.
Yeah, it's fine. I mean, I don't know. Okay, yeah, so this is going to be the last question. Yeah. Yes, okay, I'm going to call on one more person. Sanvi.
It is an arithmetic sequence because it's times 2 every time. So 1 times 2 equals 2, 2 times 2 equals 4, 4 times 2 equals 8.
Okay, you were that was really good. I'm really, really glad that you noticed that. So that's actually not an arithmetic sequence because in an arithmetic sequence, we're adding stuff. What you just told us was geometric sequence. So that's something completely different. And I think me and Avery are going to explain that next class. So a geometric sequence is different from an arithmetic sequence. In an arithmetic sequence, we only add stuff, but in a geometric sequence, every term gets multiplied. So the multiplying constant is the same. So you were really close, but it's wrong because in arithmetic sequence we're adding stuff. Now from the first and second term we're adding 1, second to third we're adding 3, third to fourth we're adding 4. So wait, what's the question mark for? Do you have a question? No. So we're multiplying 2 in the sequence, right? Times 2, times 2, times 2. So it'd be a geometric sequence. But I don't really think I don't think we'll talk about that right now. We'll talk about next class. So yeah, it's not an arithmetic sequence.
Yeah, just remember that in an arithmetic sequence, you're adding or subtracting a term each time. But in a geometric sequence, you're multiplying or dividing a term each time.
Okay, go to the recap, baby.
Okay. So here's a quick summary. If we're given a list of numbers, we need to look for a arithmetic pattern that is repeated. In other words, to get from one term to the next, you need to add the same number each time. And it could be added or subtracted. And the number that's added or subtracted is called the common difference. And to find the sum of a set of n numbers in an arithmetic sequence, here is the formula. Just to reiterate, we're adding the first number and the last number together, and then we're multiplying by the number of numbers, and then we're dividing by 2. And
yep. Oh yeah, sorry. And yeah. You continue that. I thought I was gonna say something else. Go on.
So and to get the nth term in a sequence, you take the first term and then you add the common difference multiplied by n minus 1. But
And
this
yeah,
this
that was kind of common sense. But
yeah, this one, just try to think it out. Don't just always apply formulas. Try to make sure you understand them, and you can apply them without memorizing.
The x is kind of weirdly placed. That's just multiplication. You know, after doing algebra for so long, that kind of feels like a variable. I don't know. It's just so weird seeing an x between two parentheses. But yeah. And so the things that I want you guys to take away from this, remember the leaps that I told you about. The thing that we just went over. First term times n minus 1 is how we get to the nth term of the sequence. So remember the leaps thing. 1/2, the first term plus the last term divided by 2 times the total amount of terms. That is the sum. That is the sum of any arithmetic sequence. And finally, this probably is going to come in handy. The formula for the sum of the first n integers, positive integers, is n times n plus 1 divided by 2. So that is basically everything that we have for you today. And if you want to practice more, you guys can go to Alchemist at artofproblemsolving.com. You go to the algebra section, click arithmetic sequences /series, and you can practice more of arithmetic series on AOPS. We didn't get there today since we ran out of time, but that's okay. If you guys have any questions, please stay behind, and everybody have a great winter break. I don't know, are we having class next? Well, I don't think we're having class, are we, next week?
No.
Yeah. We're not having class for winter break. I guess we'll see you guys in 2021.